Hi everybody, welcome to the technical deep dive on low-code, no-code API development with Azure Serverless. I'm Shah Mohammed, working as a lead software engineer at Cloud9 Technologies. We are a Microsoft Silver partner and Microsoft High Potential partner, providing consultation and services in the Southeast Asia region and India. Based out of Kuala Lumpur, Malaysia, we have our presence in Singapore and India as well. Our client portfolio inclusive of Petronas, UEM Berhad, Maybank in Malaysia, Jurong Port of Singapore, and Yes Bank of India as well. So let's move to the presentation. This is going to be our agenda for the webinar. So we'll start with defining what is low-code and no-code, what are the benefits of that, and focus on what is serverless computing and what are the benefits of using serverless computing. And then let's shift our focus on Azure Serverless and covering specific topics on Azure Serverless offerings such as Azure Logic Apps, Azure SQL Serverless, Azure API Management for Serverless, and Azure Functions. And finally, we shall conclude this webinar on a demo that we build a B2B API using low-code and no-code approach. Low-code, no-code. So low-code, no-code basically means the creation of application software through GUI and configurations instead of traditional hand-coded computer programming. This technology traces back to the rapid application development tools such as Visual Basic of 1990s. And basically this relies on declarative development tools including domain languages. What you see is what you get: user experience definition, flow diagramming, and visual data modeling. So if we have a look at what are the benefits of low-code and no-code development, since there's less code or there's no code that we write by our own hand, we tend to get fewer bugs because of the less code. And also the lower initial cost, basically to set up this environment for the development, training, deployment, and maintenance as well. And also this provides a shorter time to implement the full system. So Forrester research done in 2016 shows a huge cost and time benefit in developing applications through low-code approach. Serverless. So serverless is a cloud computing execution model which is based on dynamic resource allocation, and pricing is based on your consumption. So you don't need to pay a predefined or a boxed cost. So you only need to pay based on your consumption. So benefits of serverless computing is basically it provides a simplified process of application development. So many low-level details are hidden from the developer, such as scaling and resource allocation. And developer doesn't need to worry about infrastructure management. So basically this gives the possibility for a developer to not to worry about OS upgrades and downtimes because of the OS upgrades. And also serverless computing comes with a cost benefit. So if you have an unpredictable workload where you cannot really define like whether this workload is going to be high for the entire month or for the entire year, maybe it only goes high for a particular period of the time or whatsoever, you don't need to pay for that. You don't need to pay a fixed cost. Rather, you will end up in paying just for your consumption. And since this serverless computing provides the simplified process, this improves the productivity. So the developers may focus on the business logic without worrying about or have a less concern on non-functional requirements. Azure Serverless. So Azure Serverless is basically an umbrella term which includes the shown technologies and services focusing on developer productivity and cost efficiency. So this platform is based on Azure Event Grid to manage all events that can trigger code or logic, Azure Logic Apps to design workflows or orchestrate the process, Azure Functions to execute your code based on events that you specify. Not only limited to that, but also Azure Serverless is available as an option in Azure offerings on database, storage, security, IoT, analytics, and intelligence as well. So to start with the low-code, no-code approach, we will get a brief introduction on these Azure Serverless resource types. They are Azure SQL Serverless Database, Azure Logic Apps, Azure API Management, Azure Functions. And later we will implement a serverless REST API using these components and low-code, no-code approach. Azure SQL Serverless Database is a compute tier for single databases that automatically scales compute based on workload demand and bills for the amount of compute used per second. The serverless compute tier also automatically pauses databases during the inactive period when only storage is billed and automatically resumes database when activity returns. And this follows the VCO model. We can define the number of minimum and maximum VCOs based on the VCO. The memories also will change. Inactive period to auto pause can be configured so that the given period of time of there's no activity, meaning no session and zero CPU usage, the resource of compute will be automatically paused, and from that point to auto resume, the resource will not be charged. Automatically resumption we get triggered on any operation on the database, such as a new session, login, data query, data mask, operations, etc. Billing granularity is per second compared to the provision tier, which is billed per hour. The latency to auto resume and auto pause in a serverless database is generally order of 1 minute to auto resume and 1 to 10 minutes to auto pause. So if you see in this diagram, you can see the blue line which defines the minimum number of CPU cores that are going to be used, and the orange line defines the maximum number of CPU cores that are going to be used. And if when you have an inactive period for 1 hour, maybe the starting from the 2200 from 2200 into 2300, based on this inactive period, the database compute will be paused starting from 000 to 400. Azure Logic Apps. This is a cloud service that helps you to schedule, automate and orchestrate tasks, business process and workflows when you need to integrate apps, data, system and services across enterprises or organizations. This is a serverless offering unless you choose to go with the premium tier, which is also known as integration service environment. So with the serverless tier, you only need to pay for the performed executions and actions in that Logic app. Logic Apps is an Azure resource type in which you can do no-code development using the inbuilt visual designer and incorporating with 100+ connectors that are already available to communicate with HTTP endpoints, query to SQL databases, perform operations on other Azure resources in same subscription, communicating with third-party ERP and CRM solutions such as Automatica, Acton, etc. Azure API management is a way to create consistent and modern API gateways for backend services. This API management helps organizations to publish APIs to external, partner and internal developers to unlock the potential of their data and services. Azure API management also has a serverless tier for which the billing is again based on the consumption only. So Azure API management is a way to implement cloud gateway pattern to encapsulate your internal services and expose them in a generalized manner without writing code. With Azure API management's gateway pattern, you can easily achieve security, custom routing, URL retypes, protocol translation, auditing, and etc. with just a couple of clicks. Project is the place where we define how the request is going to be processed. Starting from receiving the request from in the front end, process the inbound request, process the outbound response, which is coming from the backend, and error handling as well. Azure Functions allow you to run small piece of code called functions without worrying about application infrastructure. With Azure Functions, the cloud infrastructure provides all the up-to-date servers you need to keep in your application to application running at a scale. In contrast, Azure Functions differs from Azure Logic Apps as we need to write code in Azure Functions. But the concepts such as triggers are same in Azure Functions and Logic Apps, which invokes the Azure Function or the Azure Logic App. With Azure Function, you are not locked with Microsoft languages. You also can choose from a variety of languages such as JavaScript, Python, PowerShell, and also C#. In-portal development is the specialty in Azure Functions. So without the need for an integrated development environment or a text editor, you can write your own functions in Azure, in the Azure portal itself. On the other hand, IDE and text editor supports are also available for Visual Studio and Visual Studio Code as well. In-portal development experience actually boosts the productivity. Azure Functions provide the SDK which is available for Windows, Linux, and macOS for local development. And Azure Functions can be authenticated with the integrated security feature. So you can authenticate HTTP triggers in Azure Functions using tokens from Azure AD, Microsoft accounts, Facebook, Google, etc. That's defined in the authorization header. So now we have seen the Azure technologies that we are going to use to implement our demo scenario. So let's see what's the demo scenario now. We are going to develop a serverless B2B API using low-code, no-code approach based on the resource types we discussed previously. This B2B API is a REST API, which is stateless as well. Upon development, this B2B API can be used by third-party software houses and partners to develop their own software leveraging the developed B2B API. So later, this API can be monetized. You can think of a scenario where you are a bank and open the API access to your bank's internal system to your partners, for example, payment service providers. So they will create their own software to perform payments using your API. In our demo, the API is about managing tasks for demo purposes. There are 5 operations that are going to be provided in our API. They are creating a task, getting information about a task, get all tasks and their related information, modify a task, and delete a task. A task element contains information such as task title, task description, and task status. Backend of the B2B API is Azure SQL DB Serverless. Logic is designed using Azure Logic Apps and encapsulated with API management. So if you are providing access to a B2B API to your partners, we should make sure that that the API follows the proper standards. So each of the API endpoints will have API in a route in the demo, and in case we roll out a new API version in future, we will add the version information as well, such as API/v2 or something. Using Azure API management, we will see how we will end up in rewriting the URLs by receiving the URL that are defined in the API specification that you can already see in the screen and reach the appropriate Azure Logic Apps trigger. So to wire up all these Azure resources together, let's build the B2B API gateway front-ended with the API management, which will trigger the appropriate Logic App backend, where the Logic is written to perform the relevant activity in Azure SQL Serverless database. Later, the B2B API can be accessed with the subscription key defined for each third-party software houses for the partners who are going to build their own product leveraging our B2B API. As I mentioned earlier, we can monetize the API based on the subscription key as it is unique for each of the third-party developers. Without writing a single piece of code other than the table creation SQL queries, we will develop this B2B API. We also will see how third-party software vendors are going to ensure the serverlessness in this architecture by using Azure Functions to call our B2B API and protect their API endpoint using Azure AD. So let's go to the demo. So we are in the Azure portal, and for the demo purposes, I have created two resource groups. One is to place all the resources for the B2B API, and the other resource group is basically to put all the resources that are going to be consumed from this B2B API. So let's go to the resource group where we put the B2B resources. And if you can recall my previous presentation, that our B2B APIs kind of consist of three Azure resources: Azure SQL Serverless Database, Azure Logic Apps, and Azure API Management. So let's, because Azure SQL Serverless Database is going to be the backend, or the place where we have the persistent storage of this API. So let's start creating that resource now. So click this add button and you will be taken to the Azure Marketplace. Search for Azure SQL, where you can see the Azure SQL creation blade. So here, make sure you are in the Azure SQL databases and select the resource type to single database. I mean, these are the default option, and click this create button. And make sure you are in the correct subscription and resource group, and give a name to the database. Let's say it's a low code, no code serverless SQL. So quite a big name, but yeah, it's a valid name. And let's create a new server for that. So it's low code, no code server. Yeah. And the SQL admin is Isham, and let me give the password. Passwords are matching, and select the region is Southeast Asia. Yeah. Now the important part is here to select the compute and storage option. So if you click on this configure database, you can see the serverless option. By default, provision is selected, but you can click on the serverless to select serverless. And here you have the options to select the maximum vCOS and minimum vCOS. By adjusting these values, you can see the maximum and minimum memory allocations are also changing. And here you can select the auto pause delay. So by default, the auto pause is enabled, but if you are willing to go with, you don't need an auto pause, you can disable that too. But if you select this auto pause, you can provide the time span for the inactive period. So maybe you, in this case, we have to wait for 1 hour for the database to be inactive. So then this will be auto paused. And here we can see the cost. So the storage cost is default, kind of it's a fixed cost, and the compute cost basically varies per second. So let's apply these changes. Go to networking, enable the public endpoint, because we need to make sure this database is reachable via Azure Logic Apps. So I am enabling this allow Azure services to resources, Azure services and resources to access the server. And also let me add my current machine's IP address, so I can connect to this SQL resource through Azure SQL Studio. And let's go to additional settings and keep all these settings as it is. Tags, let's, it's a good practice to have tags, but for this I'm not going to have already, and let's create this one. Alright, now the deployment of the serverless SQL database is ready, so let's go to that resource. Because we need to get the server name to connect to the database through Azure. So now I am in the Azure Data Studio. So this tool is a lightweight tool to access your SQL resources in Azure. So you don't need to install a heavyweight tool like SQL Server Management Studio whatsoever. So you can use this tool, Azure Data Studio. So click this new connection button to connect to the server. Let's paste the server address here. Username is Isham and password is something I have provided already, and connect. So now it's connected. So So to make sure the database is listed, yeah, you can see the low code, no code, serverless SQL database is already here. So now I can create a new query here. Basically, this query is to create the table for the tasks, persistent storage. So this task table is going to contain a task title, a task description, and also a task status along with the task ID. So we have this table creation query given in this repository. We shall share this GitHub repository with you to get all the codes that we are using in this demo. So let's just go to do this SQL query, this one, and paste it here and run. So now the table creation is completed. So maybe just to make sure if it works, let me do a select query. Run it. Yeah, the table is created. There's no data so far. All right. So now we have created the persistent storage of our B2B API. So this is now the time to go back to the resource group again and create the logic apps. So if you recall again, our purpose is to have five endpoints or five operations that we are going to do from our B2B API. One is about get a task, get all tasks, create a task, modify a task, and delete a task. So let's create a logic app to get all the tasks first. So let's go to the marketplace and search for logic app. Here you can see the logic app creation wizard. Make sure you enter the correct subscription and resource group. Give a name. Let's give the name say get tasks logic app, and keep other settings as it is. Make sure the location is also your closest data center. Create. Now this deployment is complete. Let's come here. In logic apps, there are some templates to start with. So the template that we are going to use is this HTTP request response, because the nature of our logic is that it's basically a REST API, right? So we can start with this HTTP request response, but also you can see that there are some other several templates. For example, you can get if there is a tweet met some hashtag, you can post something to the Slack, and also if there is an email arrived with some files, you can add it to the SharePoint. There are a lot more. So, but for this purpose, let's start create this logic app with HTTP request response template. It's pretty straightforward. So each of these HTTP requests, when it's arrived, there will be a URL that will be generated for this logic app after saving this one. So let me just save this, at least so you can see the URL. It's pretty long and complex. So, and you can select the method, which is the HTTP method for this call. So since the call is about getting tasks, the method should be get. Now, in between this request and response, I can create an action to basically call the SQL server. So now I need to get all the rows. So let me select get rows. And authentication type is SQL Server authentication, where I need to provide the name for this SQL Server, which is low code, no code server dot database dot windows dot net. SQL database name is this one, which is basically low code, no code, serverless SQL. Username is Sham and password is this. And I can create this connection. So now the connection is already ready for me, and now I can select this server name and database name and the table name as well. So all these things, if you see, they are pre-populated. So now basically I'm getting all the rows. I'm not going to give any parameters here, and in the response what I'm going to say is that show me the list of items as a response. Now I can just save this one. The good thing in Logic app is that you can clone this one. So you can clone this this existing setup to create a new Logic app. So let me clone this to create a new Logic app to add new tasks. So the name of that will be post task Logic app. So same subscription and same resource group will be used and create it. Deployment is in progress and deployment succeeded. Let me, if I go to this resource and click on this edit, here you can see the same template or the same setup for the previous one is used. Now I need to, my purpose for on this is to basically insert a new row, right? And also I had to do some further modifications. So just I need to remove this get rows part. So this is a dependency. Let me remove this one and remove this item as well. And when it comes to the HTTP received, this URL is now changed. So since this is about creating a new task, which is the post the task, the method should be post. And we need to provide the JSON schema for that. So you can, if you have a sample JSON, you can generate this schema by clicking this link, and we can provide the sample JSON here. So I have a sample JSON in my repository to which carries the title, description, and status of a task. So let me just put those here and done. Now Logic Apps create the schema for me. Now what do I need to do is that I need to add an action to create a new row in SQL, which is the insert row part. Select the server name, database, and table. Now these options are coming here. So the title should be matching the title, and the status should match the status, and also I need to add the description as well, which should match the description that is coming through the HTTP request body. So once created, the response should be the body of this SQL insert execution action. So now let's save this one. So now let me copy this URL and go to Postman, paste it, and make sure it's a post method, and write the body now. Let me write the body based on the same JSON reload. So here let me just put this information ICT and click send. Now this task has been created. So the problem that we have facing here is that the complexity of these URLs, and also when we try to distribute this as the API to the people, we need to also monetize. So we need to make sure, or we need to segregate who are calling these APIs. So that's where this API management comes. It's a handy tool, and also we can rewrite the URL. So in Azure Marketplace, search for API management. Create. And a very important part here is the pricing tier. So click consumption or select consumption tier when you choose the pricing tier for API management service to ensure the serverlessness. Let's make sure the subscription and resource group are correct. Give the organization name as CloudEnet and create. Oh yeah, so we are missing the API management service name here. So let's give the name as API. Let's see if that name is available. Yes, it's available. So let's create it now. So the problem that we have facing here is that the complexity of these URLs, and also when we try to distribute this as a API to the people, we need to also monetize. So we need to make sure, or we need to segregate who are calling these APIs. So that's where this API management comes. It's a handy tool, and also we can rewrite the URL. So in Azure Marketplace, search for API management. Create. And a very important part here is the pricing tier. So click consumption or select consumption tier when you choose the pricing tier for API management service to ensure the serverlessness. Let's make sure the subscription and resource group are correct. Give the organization name as CloudEnet and create. Oh yeah, so we are missing the API management service name here. So let's give the name as API. Let's see if that name is available. Yes, it's available. So let's create it now. So the deployment is succeeded. Let's go to the resource. And here you can see the two important options that are the APIs and subscription. So the subscription is the place where you can generate that subscription key for each of your consumers of this B2B API. So later you can monetize them, or monetize these APIs based on the subscription key. So this API is the place where you can define these APIs. So let's go to this API. And here you can see already there is a out-of-the-box connection to connect to Logic Apps, which is a pretty cool functionality in this Azure API management service. Let's select Logic App now. So here you can select which Logic App to call. So let's start with Get a Task Logic App. So it basically fills all this information for me, and I need to put the API URL suffix as API. So now you can see the URL will look like both the base URL will look like something like this, which starts with the Logic Apps URL, and the suffix is also suffixed. Create it. And Azure API management will more or less do a lot of things for us. Especially it takes this intelligence route where it can identify the route parameters and put it for us. And the important thing is that this is the front end where we receive the request from, and this is the place where the inbound processing happens. So if you see the inbound processing, here we have the URL rewriting part. So basically this URI is being rewritten to reach out this URI, which is the URI for the Logic App. And once it gets the response from the backend, it is basically doing this outbound processing and will give the response. So if there is a OK response, it will throw, or it will give 200 OK, or if there's any error, it will throw 500 internal server error. So if you can recall the API specification to get a task, it actually comes something like this. ID. So now we can test this one. Just let's save it, and we can test this out as well. So if we go to the testing part, you can see how the API will look like. So this is the base URI, and this is the suffix, and this is the task/ID. And here we have special header called OCP API and subscription key, which is a master key or master subscription key for our internal purposes. We shouldn't share that master subscription key with our consumers. Rather, we have to create one for them. So, but let's for the testing purposes, let's use the master key and send the request and see if it gives the response. But you can see now one or more field is missing, but the field missing is that the ID. So let's give number 1 to the ID and send again. Yeah, now this gives 200 OK, which is basically giving the response. So if you want to test this in Postman, just copy paste this URL in the Postman and make sure it's get method, and in the headers you should define the subscription key. So without that key, this call will fail. So to get the master key, we can click this icon to get that master key. This and send. Alright, now this is created. So now we are almost ready with the B2B API to get a single task. Let's do the same for get all the tasks and creation of a new task as well. So that's very easy. Before that, I need to do a bit of a modifications in this request invoke one, where in the design part, I need to change the display name as get task. Right. So then I can easily clone these operations. So now I'm going to clone this operation where the display name is get tasks and the URL is tasks. There's no IDs, there's no ID involvement here. And in the backend, this get task is still calling the get task logic app. So now I need to edit that by selecting the get tasks logic app. Save. So now everything is fine, and if I copy this tasks endpoint, let's keep the same headers and everything here, and if I alter this Postman call to tasks and send it, this should give me all the tasks, which is correct. So now we have created the end-to-end the B2B API without writing a single code other than the code that we wrote for the table creation logic. Now it's all about creating a new subscription key. So here we can go to the subscription blade and add subscription. Give a subscription, say for example, they are giving this subscription to the General Tasks Corporation, which is a fictive company. So let's say this, the name of the subscription is General Task Corp. Display name is also the same, and scope should be the API, and the API should be this get task logic app API. And we can allow tracing also. Let's keep the default value and save it. Now we can see the primary key and secondary key for the General Task Corp subscription. So if you go here and show hide keys, you can copy the primary key, and now you can make calls based on the subscription key on behalf of General Task Corporation. All right. Now the B2B API is ready. Now it's all about, and we have actually shared the subscription key with the General Task Corporation people as well. So now it's about the creation of the Azure functions. So this Azure function will basically be created on behalf of the General Task Corporation, or it will be done in the General Task Corporation software developers, where they consume this B2B API and expose the data to their customers. So let's go to Azure portal and go to the resource group that we have created for General Task Corporation. Here let's you see the organization is General Task Corp. I just tagged this one. to avoid the confusions. And let's create the Azure function now by going to Azure Marketplace and search for function app. Create it. Make sure you are in the correct subscription and resource group and give a function app name. So here let's give something like this. Scope API will be a better name. Yeah. And the code and runtime stack is .NET Core. Version is 3.1 and region is Southeast Asia. Even though we are going to write this code in as a Azure portal function, let's just select this option. And in the hosting part, let's make sure the function's operating system is Windows, and the important part is the plan type, which is consumption, which makes it is serverless. Monitoring, let's keep all these settings as it is and create this Azure function resource. Now the resource is ready, and let's go to the resource. So now we can see the function or the web trigger URL is something like this, which is more meaningful in our case. So we can already see some code that is already auto-populated, but I am going to use a code to get all the tasks that I have already written, which basically communicates with the API management gateway and do the job for us. Let me just copy paste that code, and let me go through that code briefly. So here we are getting an environment variable called getTasks API, and also another environment variable called API subscription key from the settings of the function, which is not yet defined, but we will define it now. And later we just make sure, we basically build the HTTP request call that we have already made in the Postman in code. So this will give the response. So let's just save this one and copy this getTasks API and go to the functions configuration by going to the function and click this configuration. Here you can see a bunch of application settings. Let's add this setting already. And this getTasks API it looks like this, right? So yeah, let's paste this and okay. Let's save this. So by saving this, basically restart the web application, which is the Azure function. So now the restart is successful. Let's go back to the function again and take the parameter or the environment variable for the subscription key, because our plan is to put the subscription key also in the application settings. So the environment variable for the subscription key is API subscription key. Let's go back to the configuration of the Azure function and add that setting too. So basically the subscription key is this, which is dedicated for general task operation. Okay. So let's just save this one, which basically restart the Azure function. So the function is restarted. Let's now create another function to create a new task by clicking this plus button. Select the same HTTP trigger option and function name is create task, and function authorization level is anonymous, create it. And in my repository I have a code snippet to create a task for the Azure function. Just replace the code, and here we are looking for another environment variable called post task API. Let's just save this one and go back to the let's just save this one and go back to the configuration setting of the function where we add that application setting too. So basically that is something similar to this again. The parameter that we have given for post task API is wrong. So let's just edit that because it's task, right? So let's just save it and save the Azure function again. And also one important thing in the functions is that if you go to each of these functions, integrate blade, starting with let's say for the get all tasks, you can define what are the HTTP methods that can be used to invoke that HTTP trigger. So we should make sure we should use the appropriate HTTP methods. By default, get and post are selected, but in this case we should deselect post because getting should only work with the HTTP get method. And we can save it. And also if you go to the other task, which is about post, right? So we should deselect get one and make sure the post is selected and save it. So now we have done all the important edit that we were supposed to do, and let's make the call again. Now you can see this has created this task. So just change the method to get and get all the tasks again and see if this task 3 is created. Okay, that we can see. Yeah, we can see the task number 3, and in our SQL, if we rerun the select statement, we can see 3 tasks. So so far we have seen how the general task operation can use this API, that was API gateway, which is coming from the API management, and our B2B API to create their own API and give it to and use it in their softwares. The important thing in end user API such as this is that they need to be authenticated. So for the authentication, Azure Functions already supports this authentication out of the box. So you need to go to the platform feature blade where you can select authentication or authorization for this function. By default, the app service authentication for this Azure Functions is off. You can make it on by enabling it. And here are the out-of-the-box authentication providers that you can select. So in our demo purpose, we are going to use Azure AD. So let's say login with Azure AD. And we need to now configure the AD application. So let's click on that and let's do it in the Express mode. Click Express, which will automatically create everything for us. And let's name the application as it is by General Task Core API. And okay. And if we just save this one, this will basically create an Azure AD application and show the credentials to us. And go to app registrations and search for the application ID. So here we can see the application, and in the certificates and secrets, we can create a new client secret. copy that and paste it here, and we can send this call to get the access token. But before that, since we have enabled the app service authentication to this General Task Group API, let's see if this now serves the response without any authorization headers defined. So I don't have any authorization headers defined for this call, or maybe I can basically copy this one and create a new response from scratch. There's no headers, so there's no body that define. All these are the default headers set by Postman. Send it. Yeah, now we can see the call is not authorized. Yeah. So now let's take the access token from here and copy this access token in the bearer token part of this one and send it. Now this serves the response. So now, so far we have seen how to build a B2B API without writing much of a code than this table script logic or table creation script, and then the consumer API, and also protect the consumer API using Azure AD. So far we have seen how to develop a pure serverless B2B API and consumer API using low code, no code approach, using the technologies that are already available in Azure Serverless platform in a very short time. As a Microsoft partner, Cloudinet provides services such as cloud migration, cloud adoption, app modernization, serverless assessments, IT security assessment, etc. And Cloudinet also offers a one-day serverless workshop. So you can reach out to us by scanning the QR code or visiting the tiny URL link and fill the form. So we will be in contact with you. So you can also visit our website cloudinet.com and reach out to our sales department directly with the email address sales@cloudinet.com. I hope you have enjoyed the webinar today, and thank you so much for your time. Have a nice day.